Let's start with the basics. A linear equation in two variables is an equation of the form of 1x plus b1y equals c1, where x and y are the variables and a 1, b1, and c1 are constants. These equations represent straight lines when plotted on a graph. For instance, the equation x plus y equals 5 is a simple linear equation in two variables where the highest power of both x and y is 1. The beauty of these equations lies in the fact that they show relationships between two different quantities like the number of rides and games a killer plays. Now, let's apply this in a real-world context. Suppose a killer is at a fair and each giant wheel ride costs 3 rupees and a hoopla game costs 4 rupees. She spends a total of 20 rupees. Let's say she took X rides on the giant wheel and played Y games of hoopla. We can represent this situation with two equations. Equation 1, Y equals 1/2 X, because the number of hoopla games, Y, is half the number of rides, kiss smiley. Equation 2, 3x plus 4y equals 20, because the total cost of X rides and Y games is 20 rupees. Now, the interesting part is, can we find the values of X and Y? Yes, we can. But how? That's what we'll explore today. Before we go ahead and solve, let's take a moment to understand the different types of solutions linear equations can have. Unique solution, the lines intersect at one point. This means there's exactly one solution to the system of equations. No solution, the lines are parallel and they never intersect. This means the system of equations is inconsistent. Infinite solutions, the lines overlap completely. This means the system of equations is dependent and every point on the line is a solution. The beauty of solving linear equations is that you can predict how the lines behave just by analyzing their relationship. This makes solving real-life problems much easier. Let's visualize how these solutions look on a graph. When we plot the equations, here's what we see. If the lines intersect, we get a unique solution. This represents a consistent system. If the lines are parallel, there's no solution. The equations are inconsistent. If the lines are coincident, meaning they overlap completely, we get infinitely many solutions, and this represents a dependent system. By using the graphical method, we can easily determine the behavior of the system of equations just by looking at the lines. Now, let's solve an example graphically. Consider the pair of equations x plus 3y equals 6 and 2x minus 3y equals 12. We plot both equations on the coordinate plane and find that the lines intersect at the point 6, 0. This means x equals 6 and y equals 0 is the solution to the system, and the equations are consistent with a unique solution. When solving graphically, it's helpful to calculate two solutions for each equation and plot the points on a graph to find the point of intersection. Let's quickly recap what we've learned today. A linear equation in two variables has two unknowns, and the solution to such an equation can be represented graphically by plotting lines. We explored how the lines can either intersect at a single point, unique solution, not intersect at all, no solution, or overlap completely, infinite solutions. Through an example, we saw how to graphically find the solution of a pair of linear equations. I hope you now have a clear understanding of how linear equations work and how we can visualize solutions graphically. In the next video, we will explore algebraic methods like substitution and elimination to solve these equations more efficiently. See you in the next topic.